Hi there guys, in this video we're going to take our binomial expansion a little bit further. There's some pretty tricky questions coming up today, so please feel free to pause the video at any point, have a go, and then see if you can get that warm fuzzy feeling. Right, so we make it a little bit harder when we just look at certain terms. So for example, this one's not a bad one. It's just a nice little warm up for you. So find the coefficient of the x cubed term. So we're not asking you for the first four. Just want you to dive straight in for just one of them. Now to do this, you can write out all four and then just look at the x cubed one, or the first four rather, or all six if you really wanted to. But that'd be a waste of time. So at the moment, how can we jump in? So we know we're going to have 5 and we're going to choose, we're not too sure at this point, but we know we're going to write down both of these terms. So we're going to write down a 4 and we're going to write down a minus 2x. Now we have to think about the powers a little bit. The powers have to add up, this power here and this power here have to add up to 5, but how are we going to get the x cubed term? Well, from this first bit we're not going to get any x's at all, so we don't have to worry too much about this one. But this one has to be the 3, because when I expand this, I'm going to get x cubed, which means this has to be a 2. Now if you looked at all the patterns earlier, well in the previous video, sorry, this number was always the same as here. It really doesn't matter which one it takes, because of Pascal's triangle being so symmetrical. You'll see that have 5 choose 2 and have 5 choose 3 is identical. But I'm going to put the 3 there. Honestly, it doesn't matter. Now we just have to work this out. So, you need to grab your calculator, or maybe you can be brave and just try it without a calculator. So have 5, choose 3. No, I'm going to use that. Okay, that's 10. So we've got 10, lots of 16, odd power, so this is still going to be negative, so minus 8x cubed. Okay, I'm just going to type that in. So I'm lazy. Today it's late at night. So minus 1280 x cubed. So the coefficient of the x cubed term is minus 1280. Coefficient just means the number in front of a variable. Right, so this is a better question. We have some unknowns in here. So we know this function g in terms of x is written as 1 plus kx to the power of 10. Okay? This time, if we have an unknown here, we have to tell you something. So the coefficient of the x cubed term is 15. So again, we're only looking at the x cubed term. So let's go and find it. We have 10, and we're choosing probably 3, right? But let's have a look. So it's going to be 1 and kx. To get the x cubed term, that has to be a 3. Therefore, this has to be a 7, because the powers must add to make 10. In this instance. So I'm going to put 3, but I could also have put 7 there. They are the same value. So let's work this out. What is have 10, choose 3? That is 120. You've got to love 1s as a base value. You can just ignore them. So we have 120 k cubed x cubed. That is what we would get out of here. But we're told now the coefficient of x cubed is 15. So we have a coefficient here, so therefore 120 k cubed is equal to 15. Now 15 divided by 120 is 1/8. So then cube root, so k is equal to a half. It's as simple as that. Now, let's up our game. This is way more difficult, because now again we're going to stick with the x cubes. But what is the x cubed term in this expansion? Okay, so we have this is a binomial, but there's only to the power 1, so it's not really anything too difficult. Here is another binomial, but this time to the power 7. But we're also having to multiply this bracket by this one, and what is the x cubed term? Wow. So we do really need to start thinking. So if you think about multiplying these out, I need to multiply this by something in here, and I'm only interested in x cubed. Well, I have to multiply this one by the x cubed term in here. So we definitely need to find the x cubed term. But the 2, I'm going to multiply by something in here. And to get x cubed, I need to find the x squared term. I'm not interested in anything else. Okay, so that's what we're going to do. So for the 3 minus 2x all to the power of 7. Okay, so we're going to have 7, choose, not sure at the moment, 3 minus 2x. I want the squared term, and I'm going to write it again, and I want the cubed term. So if that's a 2, this has to be a 5. I'm going to put a 2 down there. If that's a 3, that has to be a 4. I'm going to put a 3 down there. Again, that could be a 4, and this one here could be a 5. I'm going to just change from the pink. That's pretty awful. So have 7 choose 2. That's 21. Lots of 243. And even power, so this is going to be positive, so we can have 4x squared. Let's just type all that in while we're here. And we get a massive number, 20,412 x squareds. So what is have 7 choose 3? 35. So this time we have 35 times 81 times minus 8x cubed. And let's type all that in. And we have minus 22680 x cubed. Right, so what we basically have is this question now. 2 plus x being multiplied by something in here. It's not the start, so we're going to write 20412x squared minus 22680 x cubed. Always put the dots because it's acknowledging that there is something else. For example, there'd be an x term, a constant term, x to the power of 4 term, and that would go all the way up to the power of 7. You could have written them all, but what a waste of time. Because I'm going to do this one multiplied by the x cubed term and the x term multiplied by that. So I've actually got to times that last one there by 2. So I have 45360, that's a minus in fact, x cubed, plus 20412 x cubed. So just type that in. So the answer is minus 24,948 x cubed. Okay, so it's a big number, but when the expansion is so high, the numbers get pretty big pretty quickly. Okay, let's have a look at another one. Now, this question, you definitely want to pause, you definitely want to write it down, or parts of it, and have a go. I'm just going to make it smaller, because I'm going to run out of space rapidly here. Okay, so part A is pretty simple. Find the first 3 terms of the power. So I'm going to just do that as fast as I can. So it helps if I turn the pen on. So have 5, choose 0, have 5, choose 1. Alright, so that's the first 3 coefficients. First term written 3 times. And the second term written 3 times. Count down the powers. Count up the powers. Just check, do all the powers add up to 5? Yes, they do. Let's work this out. So we get 1, 5, never know any of the others, 10. We've got 243, 81, 27, minus 2x, and 4x squared. So we have 243 minus 810x. What's that? 20, and positive 1080x squared. I know the next one's going to be a minus because of the pattern. It's going to be x cubed. That's still going to be a minus. Okay, so that's fine. Now the expansion in ascending powers of x of this function called f, and you can see this is what we have here, right? We've just worked that out. Up to and including the x squared term is this. Okay, we have to find all of the values of k, a, and b. So let's write it down what we have here. So we have 1 plus kx being multiplied, but instead of writing that, I'm going to write my answer here. And we're interested in this bit up to and including the x squared term. So let's think about that. I'm going to try and color code this. So that is going to give me 243. That is the only constant value I'm going to have, so I've already worked out what a is. If I times this one and this one, I've done them in the same color because I'm going to get an x term and another x term, so I can collect those together. So I hope you don't mind the orange. It's probably a poor choice, but I've gone for it. Okay, let's try and find a nicer one. Everyone loves purple. Okay, so that's the x's. Now we've got to think about the x squared terms. So I can get an x squared if I multiply the 1 by the x squared term, and also if I multiply these terms. So I'm going to get a plus 1080x squared, 1080, minus 810kx squared. Right, so let's just write down what a is. We know a is 243. That's because a is a constant value. There's only one constant value. That's done. So let's compare the coefficients of x. So we know minus 810, that's the coefficient of this x, plus 243k, that's the coefficient of this x, is equal to minus 324, the coefficient of x. So just by comparing the coefficients, I can write that formula. So let's just give us a bit more space here. So what is 243k is equal to? So minus 324 add 810 is 486, which you can see is two of those. So we get a nice whole number of 2. We like whole numbers. Makes us feel that we've got it right. Okay, so we're just going to do exactly the same thing now, but comparing the coefficients of... we can't compare the coefficients because we've got nothing to compare it to really, but b is the coefficient of x squared. Now actually, while I'm here, I say I can't do k without finding out... No, I could have, but I would naturally find out a first, then k, then b, so it's very weird the order they put it in. So what do we know? So the coefficient of x squared is 1080 minus 810k. Well, we know what k is. K is 2. So we can just do that. So 1080 minus 810 times 2. You can just type that in because of BidMass. And we get minus, so b is equal to minus 540. That's a pretty hard question for binomials. So I've got a few more that you can practice today. Best of luck with it. Let me know if you have any problems.